splice plate. When you are connecting two members, that is, you can connect a rectangular plate, and if you are doing butt weld or butt connection, you are doing a lap connection one over the another. If you are connecting at both the ends, it will be butt joint. If you want to connect that, you need additional plates along with that at both the sides, top and bottom. So for connecting that, you will be providing a plate. This plate is called splice plate. So let us understand by solving this problem. Design a splice plate to connect 300 by 20 mm plate. So this is the length of one member and this is the length of another member. Connecting with this plate, and this plate is having 300 by 20 mm. This is one plate which is the width of 300 and thickness of 20 mm. And the next plate will be having the width of 300 mm by 10 mm plate. So you are having plate of two different thickness. So what happens when you want to connect with a packing plate? There is a concept of packing plate here. This plate will be having the net distance. When you subtract 20 and 10, you will be getting 10 mm. So you have to provide a 10 mm packing plate. Now you are designing this splice plate. Load of 500 kilonewton. You have to use 20 mm black bolt and fabricated in the shop. Here you are making double cover butt joint. The top and at the bottom you are using double cover butt joint with 6 mm cover plates. The thickness of the member is 10 mm and this cover plate thickness is 6 mm. Length of bolt, they have given 20 mm black bolt, provide additional 2 mm for dia of hole, and they have given a class. When you are providing a packing plate here, you have to subtract with the beta, BPK. When you are providing a packing plate, you have this formula 1 minus 0.0125 into thickness. Check the page number 75. If you are providing a packing plate, you should have a parameter called beta PK. What is PK? Is packing constant. Beta is a constant. This constant is 0.875. When you provide strength in double shear, you know that when you are providing an additional packing plate, you should multiply this factor. This packing plate is reducing the strength. If you are not providing a packing plate, your strength would have been higher. If you provide packing plate, the strength reduces. That is why when you are using two members, make the two members into same size. This is the best way to get most of the strength. If you provide two different thickness of the plate, then at the junction you will be having reduction of the capacity. BPK is known 0.875. The common factor is pi d square by 4. They have taken out pi d square by 4. You will be getting 1 plus 0.78. So they have added and it is written as 1.78 into Fu 400 root 3 by 1.25. 90,400 Newton. Now the bolt strength you have arrived. Strength in bearing. For 20 mm bolt minimum 33 mm is required for edge and 50 mm is required for pitch. So you add that, and 40 and 60 you can provide for edge and pitch. Edge is 40 mm, 3 into 22 dia of hole, which is 60, 3 into dia of hole is 22 minus 0.25. FUB ultimate strength of bolt 400, ultimate strength of plate 410 and 1. Least is 0.606. Strength of plate in bearing is 10 mm. So what is the least of the plate which you have is strength of bearing in plate is 10 mm plate. Right now two plates are here. One is 10 mm plate and 20 mm plate. The least of these two is 10 mm. 99.384 Newton. Okay. What is the least in these two? The bolt value is 90,400. Now how many bolts are required? What is the force applied? 500 into 1000 divided by the least of the strength is 90 kilonewton. Now you need 5.5. That is 6 number of bolt. That is why they have provided 1, 2, 3, 4, 5, 6. So 6 number of bolt in a plate. So you have 2 plates. You have provided 6 number of bolt. Your edge distance is 40. If you are providing 40, this is total 300. If you cut in half, you will be getting 150. In 150, edge distance is 40. Then the rest of the distance will be 150 minus 40 will be 110. The same way 110 is here. Now, the edge distance is 40, you know, Then pitch you have provided is 60 mm. You have assumed pitch as 60 mm, providing 6 number of bolts. Now check for the strength of plate. 3 things: check for yielding, check for rupture, and check for block shear. 300 into 10, the least of the plate is 300 into 10, least thickness, into 250 divided by 1.1, 681.818 Newton. Now it is greater than 500 kilonewton. For strength against rupture, your total distance is 300. Then how many bolts you have provided, how many holes? 3 number of holes minus 3 into 22. Now you will be getting net breadth into 10, which will be 2340. Then you will be getting TDN, design rupture strength, which is 0.9 ANFU, 690.768 kilonewton, is greater than the applied force. Next is block shear. For block shear, you have to take this distance along the line 112451. This is the line 112451. So this is the length. That is the length parallel to the force. So here you are having the tensile force parallel to the force. What is this distance? 40 plus 60. So you have to take this length also. Both are same. Hence they have multiplied 40 plus 60 into 2. Into 10. Thickness is 10. You will be getting 2000. And net area is, you have to subtract the 1.5. The complete hole and half of the hole, which is 40 plus 60 minus 1.5 into 22, 1340 mm square. Now ATG is the total distance in this direction, 234 along the perpendicular distance. This is 110 and 110. So both the 110 you have to add, which is 220 into 10, which is the thickness. Your answer will be 2200. And for finding net, you have to subtract the number of holes. Now how many holes will be here? You have one full holes and 0.5. So totally 2 number of holes. Hence 220 minus 2 into 22 into 10. It will be 1760. Now you can find design block strength, TDB. Substitute all the components, you will be getting the answer. 781 kilonewton, 781,984 Newton. The same with TDB, you have or option. 2 formulas are there in the code book. For the second formula, check the least. For first formula, you are checking for the yield. That is AVG is gross area into Fy is yield. The second formula has the same area for net, that is AVN. Whenever you multiply the net area, you can see that Fu is available. When you multiply with gross area, Fy will be there, that is yield strength. And also when you are having ultimate strength, when you are applying that, there will be a factor of 0.9. Here in this component you have, if ultimate load is taken, the factor 0.9 is taken here. The same way here, if ultimate load is taken, 0.9 is taken with that. Now what is your answer for this? 728 kilonewton. Now along the direction of 1, 2, 3, 4, 6, 1. Here the 6 component is provided here. In code book you have 2 variation of block shearing. One is cutting like this. I have given this example in first class. Your section can fail in this mode. If it is coming along with this, it can come in this mode, or it can cut along with this line and perpendicular to this. Let me show you this picture. A member can fail by this mode. All the bolts are here and the member is connected with this gusset plate. If it is failing only in this line of axis, it is being failed. This is one mode of failure. This is 7A. This picture will be available in code book. 7A plate. 1, 2, 3, 4. And second mode of failure is the member can fail in this mode. This is one mode of failure and this is another mode. And for this you are having L-like section. This is what the second case where you are considering. First case is over and second case you are considering here. Both are called block shear. This can fail in this mode also. TDB is 768 kilonewton and another value will be 705 kilonewton. So the least of this is 705. This is an extra bolt or a rivet which has been provided for the cover plate for packing. Generally not designed here. Design a double angle tension member connected on each side of 12 mm thick gusset plate. This is a truss, and in a truss you will be having this kind of plates. When connecting multiple members in a truss, they will make a plate. So this plate is called a gusset plate. In a space structure, you will be having spherical balls. Airport roof will be made in a space structure. You will be having the spherical balls, and in that ball all the members will be connected. So this is called a space structure. But in two-dimensional you will be having plate. If number of members has to be connected in a single point, it is better to have a plate, and this plate is called a gusset plate. To carry an axial force of 375 kilonewton. Imagine that this is the member and this is the plate. At both the sides you are having this angle section, that is L section. In a cross section, if you are taking like this, you will be having the angle section, and in center you will be having the gusset plate. So this is known as back to back. This is known as long leg and this is known as short leg. If equal angle section are used, so what will be the dimension here? If it is 50, your connected leg will also be 50. If it is having around 75 mm and this is 50 mm, then it is known as unequal angle section. This is not equal. This length is 50 and another length is 75. This is unequal angle section. If you are having both 50 and 50, this is known as equal angle section. So this is called connecting leg, called the far leg. Connecting a bolt here. See the holes. So here you will be laying the bolt. Right now what you have to design is, you are taking this member and this member carries 375 kilonewton. Design the size of the member. How to design? You have to find the dimensions of the tension member. You have to use the angle section. In given data, they have indicated that you should use double angle section. Find what is the length which is required, what is the width here, and also the thickness. Okay, below that you write the solution, and when you want to find the area of the member, they will be giving a load. Since you are having an axial force here, stress is known as load by area. What is the load they have given? 375. You select a member and let that member be 250 Newton per mm square of yield strength. Assume the yield strength of the member is 250 Newton per mm square. See, in your exam problem, if they have not given the yield strength, you can assume it as 250. This 250 yield strength member is being supplied by most of the suppliers in India. So you can easily get that member. Proper data is not given in the problem, you can take it as 250. Now you know the stress carrying capacity, which is 250, 375. What is the only one unknown? Stress equal to load by area. What are the things you know? You know the load and stress, unknown component. Area, you can cross multiply. This is stress equals load by area. If you need area, you can cross multiply stress, and area will be equal to load divided by the stress carrying capacity. Now the stress carrying capacity is 250, 375 is in kilonewton, and if you want to make in terms of Newton, multiply by 1000. What is this 1.1? Is called factor of safety. When you are designing a tension member, check the table 5. You have factor of safety for that, 1.1. When you are designing the plates, you will be getting this factor of safety, and right now you can find the area. What is the area for this? 1650 mm square. Now take the steel table and select a section. How to select an angle section? Rolled steel, unequal angles, 75 by 50. When you are taking 8 mm thickness, you have 9.38, which is in centimeter square. 938 is the area. 938 into 2 will be 1876. After 1650 you can take that. So this member is being selected. Right now you are selecting only one member. The area whatever is given is for one member. Why you are multiplying by 2? You are using back to back. 938 into 2 will be 1876 mm square. Now connect with the bolt. What they have given in the problem? Use 20 mm black bolt. Check for shear and bearing. For doing that, you should assume edge distance. What is the minimum condition? Edge has 1.5 times the dia of hole. If you are using 20 mm dia bolt, the dia of hole should be 22 mm. Minimum edge distance should be 1.5 times dia of the holes. You use the minimum condition for edge and pitch, check for shear strength and check for bearing strength. Assume 4.6 grade of bolt and they have given shop connection. Fu is known as 400 divided by factor of safety for bolt is 1.25, 5 into 20 square plus 0.78. This is ANB, reduced cross sectional area. Your answer is 103 kilonewton, 103 into 10 power 3 Newton bearing strength. Taking edge equal to 40 mm, pitch equal to 60 mm. So what is the minimum condition? 22 into 1.5 will be 33. So above that they have taken as 40. And pitch, minimum pitch distance 0.5 times dia of bolt. 2.5 into 20 is what? 50. They have taken 60. So this is greater than minimum. After finding these two, you can find KB. If you are applying the conditions, E is edge divided by 3 into D naught, which is 22. And P is pitch, 3 into 22 minus 0.25. 400 is ultimate strength of the bolt and 410 is the ultimate strength of plate. So this is the ratio and finally 1. The KB is least of that, you will be getting KB 0.606. This is 2.5 a constant, KB is 0.606, D is the diameter of the bolt which is 20 mm and T is thickness. You are having a gusset plate, in problem they have given it as 12 mm. The section whatever you have decided is 8 mm thickness, so least in these two is 8 mm and Fu you already know it as 400. Now your answer will be 77.5 kilonewton. So the bolt value, what is the least in 2? 77.5. The bolt first fails in bearing. Now how many bolts are required? What is the force coming in your structure? 375. This is the tensile force and a single bolt can carry 77,568. 4.83. You can round it off, you can provide 5 bolt. Picture shows that 5 number of bolt and you have provided 40 mm from the edge, pitch you have provided 60 mm, from this bolt to the other bolt as 60 mm. So totally what will be your distance? You are having 1, 2, 3, 4. So 4 number of pitches are there, 4 into 60 which will be 240 plus you have the edge here, complete effective length. So this is required when you are designing the plate. So for the plate you should need 3 checks. So one by one let us check. You have designed the connection, now check the plate. First one is strength against yielding. What I mean by AG is the gross area, Fy by gamma MO. Gamma MO is given as 1.1 in the given data. And what is your gross area of the two angle section? 1876 into 250 by 1.1. 426.364 kilonewton. The force is 375. The strength of the member is more than that. Next, strength for tension member, ANC. Net area of the connection. Total depth here is 75 mm. What do you mean by net area is subtracting the dia of bolt. Whatever bolt dia is there, you have to subtract from the member. So you have 75 mm as the length of the member. You are subtracting minus 22. What is 22? Dia of your hole. You are providing a hole in that member. So what happens? The strength of the member gets reduced. If you are increasing more holes, the plate will be getting reduced strength. If you are providing minimum number of the holes, the plate will be getting high strength. Now you are finding rupture strength. For that you are subtracting 22 mm and minus 8 by 2. What is 8 by 2 is your thickness of the plate. What is that? is 8 mm and you will be dividing by 2. Why? Because this is 8 mm, that is short leg and long leg. Both are 8 mm, 8 mm thickness. What you will be doing is at this junction, you will be taking half the junction for shorter leg and half the junction for longer leg. That is why you are dividing by 2 into 8. So this will be the net length and your thickness is 8. Why you are multiplying by 2? You are providing 2 back to back angle sections. So the holes will be drilled in both the members. It is multiplied by 2. Now what will be your area? 784. Now area of outstanding leg. This is called connecting leg where you are providing the bolt. And another one is called outstanding leg. In outstanding leg you don't have any holes. That is why minus 22 is not here. So total outstanding leg width is 50. They are only subtracting minus 8 by 2. That is thickness by 2. 8 by 2 is effective length into 8. What is 8? The thickness. So the area of the outstanding leg is 736. Now what is beta? 1.4 minus 0.0076 W by T. What is W? T mm. Width of outstanding leg. So this is your outstanding leg and the width is 50 mm. T is thickness 8 mm and Fy is 250. Yield strength and ultimate strength. Ultimate strength is 410. B is for an angle section. W is known as width of outstanding leg, that is 50 plus W1 minus T. T is called thickness. W1 is this distance. Distance from the outstanding leg to the center of the hole. Now how 35 is being found out is, you know the edge distance is 40 mm. If you subtract 75 minus 40, you will be getting 35. So this is your BS. It will be 77. Finally, if you simplify, you will be getting beta. TDN, which is plate rupture, equals 0.9 Fy ANC. You have this value here divided by gamma ML plus beta into AGO. AGO is 736. Fy divided by gamma MO. Gamma MO is 1.1 and gamma ML is 1.25. 450 kilonewton, 4,50,062 is greater than 375 kilonewton, which is your applied force. Block shear failure. For finding block shear failure, you need AVG and AVN. Since this is your member, minimum gross and net area in shear log, which is 1, 2 and 3, 4. The length. What is the length here? 40 plus 60 into 4. You are only having 1 to 2. In the diagram in your code book, you will be having 2 number of holes. You have gauge there. That is why it is given 1, 2, 3 and 4. If you are having only one layer of holes, then the length itself is enough. 40 plus 60 into 4 into 8. Their thickness. Now AVG will be 2240. Next component. AVN. Net shear area. What is the net shear area is? You have taken the total length. Now you subtract only the holes. How many holes are here? 5. And if you take only the center to center distance, the whole dia you have to take 1, 2, 3, 4. But for the last hole up to its centroid is half. So that is 4.5. 4 full bolt and a half bolt. There you will be having the centroid. So that is why this area is being subtracted by minus 4.5 into 22. Now you will be getting net area 1448 mm square. The same way you have to find ATG. ATG is along this length. Minimum gross and net area in tension. This area you have to take. Since this is total is 75, you have to subtract this 35. So 75 minus 35 is 40 mm into 8. This is your gross distance. This is the length. If you see the figure in your code book, it will be given the perpendicular line, that is 2 to 3. They will be written 1, 2, 3, 4. So 2 to 3 is this distance. You know this distance as 40. So 40 into 8 will be 320. Now ATN, net distance is 75 minus 35, you have this 40 mm. From this 40 mm, you have to take only the distance from the centroid, that is half of the diaph hole. What is that? Minus 0.5 into 22. So 11 mm. You will be getting 232. Now you will be getting all the values. You can substitute in the formula. Now if you are substituting here AVG, all the values you know. Fy, gamma MO, ATN, AVG is 2240, Fy is 250 by root 3, gamma MO is 1.1 plus 0.9, ATN 320 into 410 divided by 1.25, 362 kilonewton. Now another formula you have 0.9 AVN Fu by root 3 into gamma L plus ATG into Fy divided by gamma MO. Substituting all these values, AVN is 1448, Fu is 410, gamma ML is 1.25, ATG 320, Fy is 250 by 1.1, 319.515 kilonewton. This is for a single leg. You have only taken a single angle section, that is why you are multiplying into 2. You will be getting that much of force carrying capacity. Your force is 375. Safe for rupture, safe for block shear, safe for yielding. These 3 check you have to do for the plate, that is the member, and 2 check you have to do for the bolt. What are they? Shear and